Assalamu alaikum. My name is Abdullah Ajmal and today I will be explaining question number 2 of our TLD assignment, which states that design a 4-bit combinational circuit by means of 4-bit binary adder. Our problem is distributed into two stages. So the first stage is in the first stage, design a combinational circuit in order to implement following functions. When the input is even number, 1 is added in order to convert it into an odd number. And the second stage is reconstruct the original value that contain odd as well as even values. The output provided by the first stage will serve as input to the stage. So in the first stage, what we have to make is that when we give our circuit input 0010, which is 2, which is an even number, so it will give us 0011, converting it into a odd number. Similarly, when we give it input of 0011, which is 3, it is already odd, so we don't have to change it, so it will give us the same output. So in the second stage, we have to make the circuit in the following configuration that it gives us the same answer which was given as the input of the first stage. So we will be using 4-bit binary adders to make this circuit. So we will construct this circuit using two binary adders. The first adder will function as adder, which will add 1 to the even number, and the second adder will act as subtractor, which will subtract the one number that was added to the previously even number. So we'll now move on to explanation and the logical diagram. So this is the logical diagram. So this is 4-bit adders. The first will add as adder and second will add as subtractor. Both has 4 input. So the output of the first will act as the input of the second stage, and the output of the second stage must be equal to the input of the first stage. So these are the significant bits. The first 3 high significant bits of the adder are kept as low, and the least significant bit is the complement of the D function, which is here the input last input bit. Similarly, the for the subtractor, these significant bits are kept high and the last significant bit is kept as same as D. So this is the explanation that when we give even number as an input, it will detect that it is an even number, so it will add 1 and give us an odd number. And the explanation of second stage is also given, which shows us that when the output of the first stage is given to the second BCD, which second our 4-bit adder, it will act as subtractor due to these high bits, and it will give us the same answer which was given to the first circuit as its input. So we will now move toward our protein simulation. As you can see, I have already made a circuit using these components, which is given. This is a keyboard, this is the IC that converts the keyboard inputs into simple BCD inputs, and these are this one first one IC of adder acts as simple 4-bit adder, and this adder subtractor due to this high out. So now we'll run our circuit. So when I give our circuit 1, so in this initial stage, our circuit the input of our circuit is 0, which is an even number. So the first output should be 1, so it has added 1 to the even number to convert it into output as odd number. And the second output should be 0, as it should be equal to the input of the first stage. So as we can see, now I will give it 1. Now as 1 is an odd number, so it will not change anything. So here the output of the first stage is also 1 and the second stage is also 1. So let's give us 2. So as we can see, the output of the first stage is 3 and the second stage is 2, because second stage should be equal to the input of the first stage. Now I will give it as 4. So output of the first stage is 5 and the second stage is 4, 6. So it is 7, 6. So this is how our question number 2, the circuit and its implementation. That's all from my side. Thank you. In the second part of this video, I will explain the working of question number 1, which requires us to make a 4-bit ALU. ALU stands for arithmetic logic unit. So basically in DLE, ALU stands for a circuit system created by using ICs that can perform different functions, basically like addition, subtraction and multiplication, and some other logics. Like it can, if you use a particular type of IC, you can also perform AND function, OR function, exclusive or exclusive NOR function with respect to the input provided. So we are making a 4-bit ALU. So these are the following instructions that are given to us. I have created the circuit of 4-bit ALU in Proteus. These are the components on the left side. These are the components that are used in this ALU. Basically, this is a coder chip that converts our keypad input into BCD input, which is further utilized by our components. So basically this circuit works on the principle of delatching circuits. There are two delatching circuits, this one and this one. So basically these circuits are used to store the values that are given by the users one after another. So the values are for time being, values are stored manually. So the first this part of the circuit, this part of the circuit performs the addition as well as subtraction, because in addition we have a zero carry. So for addition it will be like this, and when we are performing subtraction it will be converted to 1. So this is the basic multiplier chip, which gives us the product of the two inputs. This display will show us our first input, and this display will show us our second input. So let us start a circuit. So as you can see, the circuit is on and it is displaying 0. So let us give us a value. This is 2. So this is 2. In order to store this value in our delatching circuit, so we will give it a high logic 1. So now it is stored. Now if even we change it to 1 1 or 0, it will not change. Now we will give our second input. We will change it to, suppose, also make it 2 3 4. Okay, we will keep it 4. So in order to store in this second delay circuit, it is based on a internal clock. So first goes high, then goes low. So now we'll make one of them high. Now value of 4 has been stored. As we can see, it is giving us the value of 4 plus 2 is equal to 6, and 4 into 2 is equal to 8. Now if we have to perform subtraction, we have just give it value of 1. Now it is giving us value 3, which in order to perform subtraction, what we have to do in order to perform subtraction, we have to just give it a value of 1, and now it is giving us the respective value of subtraction. So this is how our circuit is working, and I have explained the basic working behind the storing values using. I have basically described the working of this complete circuit, how the delatching circuits work and how they store value in themselves. So this is from my side. Thank you.